Okay, so let's move on to number 4. Again, my preference is that you're trying these on your own and then coming back to check on them. Also, the completed notes are up on Lumen. I looked at them today and realized they were actually scanned in a different semester, and the pages are all messed up. They're not in the right order, but they have page numbers at the bottom, so I trust that you can figure out what page you're on when you're looking at it. All right, so here we have the power rule, right? We have this expression being raised to a power. So remember that this exponent gets multiplied by all the exponents inside the parentheses. Now there's one other thing it's going to get multiplied by. It is not going to get multiplied by this 2. 2 does not get multiplied by 2. 2 gets multiplied by the exponent on there. So just watch that. Okay. So I'm going to have 2 to the second power, because 1 times 2 is 2. B to the negative 6th. C to the 10th. D to the 8th. Again, in each case, I'm just taking the exponent and multiplying by the outer exponent. Okay, now once again, I'm going to write it with only positive exponents. Now let's talk about this 2 to the second for a minute. 2 to the second, 2 times 2 is going to be 4. You can just write 4 there. It's fine. Or you can leave it as 2 squared. Generally, I say if it's going to be kind of a small number, then you can write it out. If it's like 2 to the 82nd power, it's going to be a huge number. Don't write that out, right? But if you have 2 to the 3rd, which is 8, or 2 to the 5th, which is 32, I mean, a smallish number, it can go either way. So here I probably would, just because 4 kind of seems nicer than 2 squared. But either way is fine. C to the 10th, D to the 8th, those are going to stay. B to the 6th had to move down to the denominator. Now remember that we cannot do anything to combine these once they have not like bases. So 4C to the 10th, D to the 8th, the C and the D can't be combined at all. So you want to just leave things alone if they have unlike bases. Okay, number 5. We have D squared times D to the 4th raised to the 5th power. So we always want to take care of these things that are in the parentheses first, because I can't combine these two while this is still in parentheses. Okay. So one way to do it is to say, okay, I'm going to use the power rule on this. So D to the 4th to the 5th, I multiply those two, and I get D to the 20th. Now remember, what that really means is D to the 4th times itself 5 times. So if you wanted to kind of check yourself, you could do that. And here, now I would add up the exponents, I would still get 20. Now, product rule says I'm going to multiply these two expressions with like bases. I'm going to add the exponents. Okay, number 6. We have 3bc to the 5th, this quantity to the 4th, and then bc quantity squared. Okay. Again, we want to take care of those parentheses, and we also want to remember that each of these things has a 1 for an exponent. So I am not multiplying 3 times 4. I'm multiplying the exponent of 1 times 4. So I'm getting 3 to the 4th power, b to the 4th power, c to the 20th power, b to the 2nd, c to the 2nd. Okay. Now, if we only had the product rule, or we only had the power rule, it wouldn't be so bad. But it's the switching back and forth is where it gets a little bit tricky sometimes. So we multiplied our exponents here because of the power rule. Now in this case, when I have like bases, I'm going to add those exponents. So I'm going to have b to the 6th, c to the 22nd. I don't have any negative exponents, so I can just leave that. 3 to the 4th is 3 multiplied by itself 4 times. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. So I mean, that's a reasonable number. You could put 81 there instead. Either one is fine. Okay, number 7. So these on this page aren't too bad, right? We're kind of just working a little bit at a time. 1 or 2 rules at a time. So 7 says a to the negative fourth, a to the fourth, a to the negative fifth. Okay, so notice none of these are being raised to a power. They're just three exponential expressions. They all have the same base. So I'm going to add the exponents. Negative 4 plus 4 equals 0. 0 plus negative 5 is negative 5, which is going to be 1 over a to the fifth. Let's just look behind the scenes with this one for just a minute. So what does this mean? Well, a to the negative fourth would really be this, right? Then I have a to the fourth, then I have 1 over a to the fifth. So if you think about what's happening here, I have 4 a's on top, and I have 4, and then 5 more, so 9 altogether on the bottom. These would cancel out, and I have those 5 left. Right? You could have done this too. You could have originally switched all these to be positive, and then had a to the fourth over a to the ninth, and then subtract. There's different ways to do these. We'll see that, especially as we get to the more complicated ones. Okay, and number 8, the last one on this side of the page, is x to the fifth over x to the 12th. So again, quotient rule, I always subtract top minus bottom. This case it's going, oops, not x. This case it's going to give me a negative 7, which again is 1 over x to the 7th. Hopefully you can start kind of visualizing this. This would be 5 x's multiplied together. This would be 12 x's multiplied together. So if I cross things out, what I kind of call the leftovers are going to be in the bottom, which you can see here. Okay, let's flip over and look at the back here. So number 9 is going to be m to the third over m to the fifth. This whole thing squared. Okay, again, there are going to be 2 ways that you can do this. All right, so a lot of the time, there's more than one order you can do things in with these. So one thing I could do is think about the power rule. And the power rule, remember, says that the outside exponent gets multiplied by all of the inside exponents. So in that case, I would get m to the 6th over m to the 10th. And then I would subtract and get m to the negative 4th, which is 1 over m to the 4th. And that's one perfectly good way to do it. Okay, I also could look at this and kind of look at what's inside the parentheses first. And I could say, well, m to the third over m to the 5th, those are like bases. I know from the quotient rule that I can subtract those. And I would get m to the negative 2nd. And then one thing I could do from here is to now use the the power rule, multiply these and get m to the negative 4th. And then, again, change it to be positive. Okay, those are both perfectly valid. Now, when you have a more complicated situation like this, you might decide which to do based on what's inside. If what's inside can be divided nicely, you probably would do that first. Or you might want to. But if it can't be divided nicely, then you would go ahead and use that power rule first. All right, so lots and lots of examples here to go through. And you can see number 10 to the end are a little bit more complicated. So number 10 is going to be c to the third, d to the 7th, over c to the 8th, d to the negative 1st. So when we are looking at this, we see that we can use the quotient rule for the c's and for the d's. So we're always going to subtract top minus bottom, and my answer ends up on top. And then I may need to switch it if it's negative. But for c, 3 minus 8 is negative 5. Now, when you're dealing with negatives with the quotient rule, I'm going to caution you to be very, very careful, because this is a very common mistake. People look at this and say, oh, that's going to be 6. Well, it's not, because we're not adding those, we're subtracting them. So I would strongly recommend writing what you're doing off to the side. 7 minus negative 1. Well, that's the same as 7 plus 1. So your d is actually going to be to the 8th. And then we can move the c down to the bottom so that it's positive. Okay, 11. 11's not too bad, doesn't really introduce too much more. It does bring in that 0 power rule. Notice we're using the dot for multiplication, right? We can't use x anymore for multiplication. We know that because that's our variable. We don't have to use it. We could use parentheses also, right? In some places in here, it's just kind of an extra. Like we don't even need it there, but either way is fine. Okay, so we look at this one. Anything to the 0 power is 1. Sometimes people think that means the exponent becomes 1. It doesn't. This whole thing is just going to be 1. And then I'm going to have 2 times, these are like bases. I add the exponents. This is a negative here. I add the exponents and I get negative 3. Now, 1 times anything is just that thing. So I really don't even need the 1 there anymore. You can just think of this as 2x to the negative third. Now, again, I want to move things around so I only have positive exponents. Remember that example we did, right? The exponent on the 2 is not negative 3. It's 2 to the first power. So that's going to stay where it is. And then x to the third goes to the bottom. Okay, 2 more. And you can see they get a little bit, they're just a little more full, right? See where I am for time there. Okay. So, number 12. We have 5x to the negative third, y to the fifth, z, over x to the negative second, y, z to the negative fourth. Okay, so again, I'm going to look at this and I see that there's only one number. There's not a number here to divide by, but I can use my quotient rule for all of these. Now again, you have a choice. Some people like to move everything around first so that it's positive, and that's okay. If you wanted to do that, you could say, okay, x to the negative third goes down here, y to the fifth stays, z to the first stays, x to the negative second is a negative, so that's going to move. Y stays here, z to the fourth goes up there. So what I did in that step is anything that had a negative exponent, I moved around first, so now I'm only dealing with positive exponents. So then I could say 5, I have y to the fifth and y to the first. I subtract and I get y to the fourth. I have x to the second and x to the third. 2 minus 3 is negative 1. And then z times z to the fourth is z to the fifth. And then, again, I would move things around. So I have y to the fourth and z to the fifth stay up there with 5. X goes down to the bottom to be positive. Now, I didn't have to move these around at first to be positive. I could have worked with what I had here. And again, my suggestion is to write out what you're doing. So for the x's, I would have negative 3 minus negative 2, or negative 3 plus 2. There's my negative 1. Y is going to be 5 minus 1. There's my 4. And z is 1 minus negative 4, or 1 plus 4. There's my 5. Okay. So I'm going to stop this video and I'll be back to do number 13, because it's a little bit long. Before you start the next video, go ahead and try number 13 and see what you can do with it. All right?